Welcome back, everyone. So, we will now discuss the dialogues and controls that I've been talking about in the previous chapter. So, this is the most useful uh, concept that we will learn because it also highly connected to the technology that we always use, such as mobile phones. So for us to understand how those technology actually work, we need to understand the where it came from, which is in this two concept, which is controls and dialogues. Even though they may have somewhat different visual design trappings from platforms to platforms, controls and dialogues constitute a common language for users interacting with most of the digital products available today. These standard objects are available as part of most GUI development libraries, but this doesn't prevent their misuse in many software applications. Controls Controls are self-contained screen objects through which people interact with digital products. Controls, also known as widgets, gadgets, and gizmos, are the primary building blocks for creating a typical graphical user interface. Examined in the light of users' goals, controls come in four basic types: imperative controls used to initiate a function, selection controls used to select options or data, entry controls used to enter data, display controls used to manipulate how and where the application display itself and its data. Some controls span more than one of these categories. So these are the um, summarized view of what controls is, but we were gonna dig deep on this. Imperative controls: the interaction between humans and computers involves a language of nouns, sometimes called objects, verbs, adjectives, and adverbs. When we issue a command, we are specifying the verb, the statement, actions. When we describe what or whom the action will affect, we are specifying the sentence noun. So like what we've discussed in the previous video, the usual way we communicate to the icons or objects is through object verb instead of verb object. Now this imperative controls is actually the verb that we are applying to that object, which in this in English is noun. Sometimes we choose a noun from an existing list, and sometimes we enter a new one. Now there is a representation for this noun, such as a list, which we will discuss later. We can modify both the noun and the verb with adjectives and adverbs respectively. So we can change the attributes of nouns and verbs with adjectives and adverbs. The same That's actually how the icons and buttons and all that we see on our interface right now works. That's also where object-oriented programming came from, in which we manipulate objects and its attributes. In this case, the objects is the nouns, the verbs, and the way we change the attribute it's through adverbs and adjectives. A control that corresponds to a verb is called an imperative control because it commands action, most often immediately. So, most often this verb or imperative control are immediate. So that's one of its characteristics. Menu bar items discussed in chapter 18, which is the previous video, are also imperative idioms in the world of controls. The quint essential imperative idiom is the button. Button. So the button in the menu bar is actually an imperative control in which we use it to perform a command or a verb to a noun. But later we will gonna discover how this combination of verbs, adjectives, adverbs to and then noun became complex because we mixed that in this palette, tool palette or this ribbon. Uh, those are what makes this complicated. Click the button and the associated action, the verb executes immediately. So this was the first way we interact with this GUI, with these buttons. So these are the controls that we are talking about. One of the parts of imperative controls. Buttons. The button is arguably the most easily discoverable idiom in the designer's toolkit. It isn't surprising that it has evolved with such diversity across the user interface. So here, as you can see, it evolves. These are flat, while this is released, or it actually changed from depressed to pressed, or there's a highlighted. So later we will gonna discuss the how it was changed throughout the years. The manipulation affordance of Fox three-dimensional buttons prompted their widespread use. So the affordance, since affordance basically allows us to have a clue intuitively on how things actually will be used, such as this button, or like a doorknob. Like we will discuss that further in the next videos. I We discussed that in the previous book, but we will discuss that in more detail. Now here, figure 21.1, standard buttons from Microsoft Windows, top left, Apple OS X top right, Android bottom left, and iOS bottom right. Although push buttons were once given a 3D raised affordance indicating pressability, a flatter look appears to be growing trend. So first it was a 3D, now the flatter look provides a growing trend. When a user points to it and clicks the mouse button or taps the button with a finger or stylus, the button control visually changes from raised to indented. So here it was raised. When you click that, it was indented, indicating that it has been activated. This is an example of dynamic visual hinting discussed in chapter 13. So we will discuss that. So it basically provides those rich modeless feedback and the hinting that these icons are button usually have for us to satisfy our visual brain. Though flat design does thus away with this pliancy, it can only afford to do so because of the decades of training and experience users have with the rounded rectangle shape. So the reason why it worked, even though it doesn't have that 3D affordance, even because of the training of people, kind of like it became an idiom for them to discover those type of buttons. Because later we will discuss how the discoverability is important, because a function won't be used if it isn't obvious to use. Icon buttons. To populate the toolbar, buttons were adapted from their traditional home on the dialog. When buttons moved to the toolbar, they changed from rectangular to square, and their text labels were replaced with iconic ones. So the buttons, since it was adapted from a dialog box such as menu or any pedagogical way to provide information, the buttons moved to the toolbar, which made them remove the text, because otherwise if you have a button like an icon in a toolbar such as this, for example here, for example there is you can see this bold or CTRL plus B or make your text bold text, it will eat out screen real estate. When the button moved to the toolbar, they changed from rectangular to square, and their text labels were replaced with iconic ones. So the text label was changed by iconic ones such as this, and then instead of square like this in the menu before, it was replaced by square because it minimized space. Thus was born the icon button, half button, half icon. So the icon button are actually half button and half icon. Icon buttons from Microsoft Office. On the left are examples in Office for Windows, and on the right are same examples in Office for OS X. Icon buttons aren't rendered with the button affordance until the mouse cursor passes over them. So here, before the icon button was designed as won't be rendered unless the mouse cursor pass over them. The downside of the icon buttons derives not from its button part but from its icon part. Most users have no problem understanding the visual affordance. The problem is that the image on the face of the icon button is seldom that clear for a first-time user. So the problem is the thumbnail or the image that represent the icon. It takes time for intermediate or for new user to understand this. That's why they still need a menu bar to learn those using longer text explanation. Most icons are difficult to decipher with certainty at first glance, but tooltips can help with this. However, even the best icon designers will be hard-pressed to devise an icon system that will be usable by novice users without resorting to text labels. So it is hard to provide an icon because we will discuss this in the next video, that an icon actually represent an idiom for user. So it takes time for the beginner user to be intermediate. That's why it's hard for them to understand that without text. So even the best designer could not do that. In these cases, menus with verbose textual labels are better approach. Microsoft's Ribbon Control, also discussed in chapter 18, takes a hybrid approach that combines text and icons, trading some screen real estate for greater clarity and is for novice users or infrequently used commands. So the Microsoft Ribbon button, I think we've discussed this in the previous chapter, in which here, like, it combines icon and the text. So that's actually the new toolbar, but later we will discuss that further. Hyperlinks, this is typically taking the form of blue underlined text. CSS styling can play havoc with the standard in all sorts of ways, such as changing their default and traversed colors, or providing a focused highlight color on mouse hover. A link is an imperative control used for navigation. So this is another form of controls that we use to um, as an idiom, again, to achieve our goals in this or web application or in this technology. This direct and useful interaction idiom has grown beyond its simple beginnings in taking users to a web page that provides more details about a hyperlink word or phrase. So these are usually used or initially was used to discover more information about the highlighted links, such as here. Sometimes also a picture of that could be an hyperlink, but it is not that discoverable for new user and intermediate user. Also, developer could wreak havoc on this control by changing the color of the hyperlink, because people have a mental model that it's color of blue. So here, complex transactional websites such as Amazon.com rely on the simple hyperlink for much of their navigational infrastructure, which for the most part works remarkably well. Images can also be used as links. However, the lack of affordance, especially in mobile browsers, where there is no possibility of highlight on mouse hover to indicate pliancy, can be problematic. In general, you should use links for navigation through content, and buttons or icon buttons for other actions and functions. So you use this link control for navigation through content. So it's most useful for web applications or websites, and the desktop equivalent of that is buttons or icon buttons for other actions and functions. A common web tactic for dialog boxes is to present options using a combination of buttons for the default choice and an adjacent hyperlink for the other options. This is effective because a button has a greater visual weight and real estate for easier selection. Unfortunately, it has been used too often to trick users into not noticing the link and thinking they only have one option, making an expensive choice. So a dialog box, such as like I think we have discussed that multiple times, but it is a common way to use these two controls is for default option for an icon button and then hyperlink for the other option. However, people are not aware. That's why it could be used to deceive as well. So design principle, use link for navigation and buttons for action. Selection controls, because imperative controls represent commands, verbs, they need objects, nouns, on which to operate. So, since we've discussed that, so these hyperlinks, icon buttons, and simply buttons, which is a text and a rectangular shape, since it deals with command or verb to an object, here selection controls actually deals with nouns to operate. So again, we are operating something or a function. Either that operation could be addition, minus, multiplication, or division when we look at it in the developer's point of view. A selection control allows the user to choose this noun from a group of valid choices. So let's say you choose an icon, then there is a menu that could pop up that will allow you to choose what noun would you like that object or verb to apply? So that's where like object-oriented programming, which discussed in the previous video. Selection controls are also used to configure actions. So it is also used, this could be used to change the attributes of a verb, not just nouns. So you can think of this as an adverb as well. The nouns may be defined by direct manipulation idioms with selection controls, then used to define an adjective or adverb, modifying the object or action on it. So modifying those noun using the adjective or adverb action on it. Common examples of selection controls include checkboxes, list boxes, and drop-down or pop-up list. Traditionally, selection controls did not directly result in actions. They require an imperative control to activate. So before you need a list control and a separate imperative control such as link, button, or icon to activate that. This is no longer always the case. In some situations, such as the use of drop-down or pop-up list as navigation control on a web page, this can be disorienting to users. In other cases, such as using a drop-down list to adjust type size in a word processors, so we can actually do that here, in which we can change the size. So these are used to apply as a command as well to an object or noun such as the font size. So this can seem quite natural. In cases where it is desirable to allow the user to make a series of selection before committing to the action, there should be an explicit imperative control, a button. So if you only this selection control that combines the action to the noun with the verb, so that's where it becomes complicated. This principle of having an action or a noun such as this selection control immediately provide an action as well will be seen in the next videos as well, especially for mobile phones. So if you have a series of actions like a series of it could be a series of dialog box, it is best to still use the imperative controls such as links or etc. Because it could be confusing for users to determine what happened on that action. So that they are clear what actions they are used in each step of the way. It also allows for different configuration for each step, which avoid confusing, allows you to more configure it. In cases where users would benefit from seeing the immediate impact of their actions, and those actions are easy to undo, it is completely reasonable for the selection control to double as an imperative control. So this is highly related to the modal dialog box. One of the characteristics of modal dialog box is that like this, you can immediately click that from the screen, and then the icon or button is just one click away, because we can change this size, but it also has an option to undo it, because that's one of the principle to make a modal dialog box effective, which here is actually a modal dialog box. So it's a pop-up that goes and then it could vanish as well. So it's easy to undo. So later we will discuss further that. So that's where it became more complicated because of those, concepts, a combination of concepts. Checkbox, the first example of selection controls or noun that could combine these verbs. The check box was one of the earliest visual control idioms. After the user selects it and sees the checkmark appear, he has learned all he needs to know how to make it work at will. Click to check and click again to uncheck. The check box is simple, visual, and elegant. So here's an example. The user immediately knows what it means instead of providing uh, 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 the complex dialog functions, which allows you to change the properties of how this uh, function really work in the back end, because that's how you actually control that in the back end, is through dialog box function and changing its properties. But here you just immediately see that that you have checked some particular terms. So standard checkbox from Microsoft Windows top left and Apple OS X top right, Android bottom left, and iOS bottom right. Again, the trend towards flatness decreases learnability. iOS also breaks the standard checkbox idiom by using circular rather than square. The checkbox is a familiar, effective idiom, but it has the same strength and weaknesses as menus. Well-written text can make checkbox unambiguous. So checkbox is the first this of complex um, nouns, but it has the same issues with menus that we've discussed in the previous video, in which it provides a long text. However, this exacting text forces users to slow down to read it, and it takes up a considerable amount of real estate. So it forces user to read the text. Nothing is inherently good or bad about squareness. It just happens to have been the shape originally chosen. And many users have learned to recognize this shape. Don't make checkboxes diamond shaped, and especially not round, which confuses them with the visual idiom employed by radio buttons. Regardless of what your marketing department or visual designer say. So you should not change this because there's a mental model already. There's no particular reason, it's just that it's the first one. So have you wondered why square are used for multiple additive selection? It's because it's the first introduction to it. The same thing as a radio button, which we will discuss later. Toggle buttons, check boxes work well to allow binary state changes. But this idiom isn't well suited for toolbars. By allowing an icon button to stay in the push in state when clicked and then returning to the non-depressed state when it is clicked again, you create a toggle button. So the checkbox allow for binary state changes, and then this toggle button actually is the one that is being depressed and non-depressed. Okay, when pressed and or click, and then non-depressed when unclicked. So that's not actually. Let me rephrase this. It doesn't actually use this state. It is not a toggle button. It's simply just a flat square rectangle for buttons. So those are the first one. The pushed in state is no longer momentary, but rather locks in place until click again. So it's not momentarily. It's changed the state permanently. The button's toggle behavior has changed its character sufficiently to move it into an entirely different category of control. So when you click that, that means you're actually using a different control from imperative to selection. So those became more complex now. So when we push that, that's actually turned from an icon button to selection control. So this the toolbar that we see here, when we click the bold, actually is type of a selection control because it combines the nouns and the verbs. These images depict toggle buttons in their flat, mouse over, click and selected states. So here it's a flat. Uh, Here mouse over, when you mouse over there, it's highlighted. So that's different when click. As you can see, it is darker when click. And selected state. So when you if it's selected and then you remove that, it's the same color. The toggle button is superseding the checkbox as a single selection idiom. So these are the most commonly used idiom for selection control now. As you can see, you will see that in mobile apps, in desktop, in websites, it's the same as icon replacing the normal button. It is especially appropriate in modeless interactions that do not require interrupting the user's flow to make a decision. Toggle buttons are more space efficient than check boxes. So the icon button, which is just an imperative control, is not actually what we see in this modern toolbars, which is the ribbon control or sidebars. It's more like a selection control type, which is this toggle button. So this toggle button in the back end is actually consist of a noun in which you can apply a function that allows you to also change its attributes, kind of like in the back end. So that simple icon actually has many states in the back end, but we are able to get used to it because of the idiom theory. So state switching buttons. An idiom to avoid. State switching buttons are an all too common control variant used to save interface real estate. So since this selection control allows us to represent nouns or objects and apply verbs to it, it also includes this state switching buttons. So you may think that it's a normal button, but it's actually state switching button because when you click that, it will change to off. So the control is now on, but it is confusing, so you should avoid this. It's part of selection control. It's not imperative control anymore, but we should avoid this at all costs. This means that there are two very reasonable and contradictory interpretations of the icons on the button. The control can serve as either a state indicator or a state switching selection control, but not both. See figure 21.6. State switching button controls are very efficient. They save space by controlling two mutually exclusive options with a single control. The problem with these controls is that they fail to fulfill the second duty of every control, to inform users of their current state. If the button says on when the state is off, it is unclear what the settings is. If it says off when the state is off, however, where is the on button? Using switch controls makes much more sense in this instance. The solution is to either spell out the verb play or pause in text on the button, or better yet, to use some other technique altogether. So the solution is adding play and pause in the button instead of switching this state, because you don't actually know if it changed the state or if the attributes that you apply to that the object applied to the noun at the same time was applied. You don't know that visually. For example, you could replace the button with two buttons, or some audio players do, with icons for both states. Doing so would make the toggle state switching natures more explicit. If the last approach also included highlighting the icon representing the active state, it would work almost perfectly. Unfortunately, however, almost every audio player app now uses the broken state switching idiom, toggling between the play and pause icon, and most users have now become accustomed to it, for better or for worse. So unfortunately, users was accustomed on this type of button for music player app. So yeah, this could be improved. Radio buttons, fourth type of selection control, more complex object verb application, similar in appearance to the checkbox is the radio button shown in figure 21.7. So similar to the first selection control button that was invented is this. The behavior of GUI radio buttons, like their mechanical forebears, is mutually exclusive. When one button, one option is selected, the previously selected option automatically deselects. So you often see this in this mobile app. Consequently, radio buttons always come in groups of two or more, and one radio button in each group must always be selected. Presenting a single radio button doesn't make sense for the user. You should use a checkbox or similar selection control in that instance. So only one of this in this list are actually not applicable. So you should use a checkbox or similar selection control in that instance. Radio buttons use the same amount of space on screen as checkbox. More even, since radio buttons are meaningful only in groups. So these are meaningful in groups like 5, maybe 5 to 7, but a lot of this is not also applicable. So it also depends on specific use cases. Radio buttons are well suited to a pedagogical role, which means that they can be justified in infrequently used dialogues. So it's like a configuration settings or the dialog box, which we will discuss it. We've discussed in the previous. We've touched on the previous video, but we will discuss further in the next videos. But drop-down lists are often a better choice on the surface of sovereign applications that must cater to daily users. So this is where we become modern. So this is like the modern way, the drop-down list that provides this function of radio buttons. So for the same reason that checkboxes are traditionally square, like that's how we've always done it, radio buttons are always round. Icon buttons have reimagined the radio button in the same way they have the checkbox. So since this checkbox has been reimagined by toggle button using that icon, this icon also reimagined this radio button. So as you can see, the icon are very innovative way to represent our functions. If two or more latching toggle icon buttons are grouped and are programmed so that only one of them at a time can be activated, they form a bank of radio icon buttons. So instead of two, here you only have two possible states for one toggle, right? Or sorry, it's not actually radio button. So sorry, let me correct myself. Radio button actually is mutually exclusive. This is not the one, but basically you either have two or more of that in a row or column, and then when one option is selected, the previously selected option automatically deselects. So it's like here you have four option, right? When you click this, all if your previous selection is this, it will be deselected because you can only choose in either one of four selection in a group. So this icon, reimagine that from its mechanical forebears. If two or more latching toggle icon buttons are grouped and are programmed so that only one of them at a time can be activated, they form a bank of radio icon buttons. This more modern construct ends up looking and behaving more like its mechanical ancestors than the traditional circular radio buttons. So because the idiom for radio buttons are circle, so you can see that in surveys still now, this icon reimagine that. So just as with all icon button idioms, these are efficient consumers of space, letting experienced users rely on spatial memory and pattern recognition to identify them, and letting infrequent users rely on tooltips to remind users of their purpose. First-time users either will be clever enough to learn from the tooltips or will learn more slowly, but just as reliability from other parallel pedagogic command vectors. So these are used for intermediate users, especially nowadays, because it relies on patterns or on our visual brain. Now the beginners could rely on tooltips. So as we've discussed, the ribbon control and toolbar now include tooltips. When you hover this like this in bold, what is that? There. So that's the tooltip. That's where the user could rely, but as reliably from other parallel pedagogic command vectors. So tooltip has replaced the dialog boxes which are used before, or menu box or pedagogic command vectors to discuss information about the use of the button or controls. Figure 21.8 words alignment controls are bank of radio icon buttons which act like a traditional radio buttons. One is always selected, and when another is clicked, the first one return to its unselected state. This variant is a space conservative idiom that is well suited for frequently used options. Switches. So switches, the switch control is more compact version of two radio buttons used together. It is also more understandable version of a single checkbox since both states are labeled explicitly. So it is like a checkbox, but it is more understandable version of it. So again, the more understandable and intuitive it is, or affordable or affordance it provides, it's easier for our visual brain. It has two states, typically on and off, which are labeled on either side of the switch as shown in figure 21.9. So these are usually used for mobile application, but it's another form of selection control which combines object verbs, manipulation of adjectives and adverbs. Switch controls are prevalent in mobile apps such as in iOS shown here, especially on settings screen, which contains product features that can be turned on and off. Again, so these types of like this is actually hidden in settings as well, so that what used to be dialog boxes is now just like this button to change the settings. So there is a more innovative type of that, which is this combo icon buttons. A variant of the radio icon button replaced the bank of icon buttons with a drop-down list of icons. So here, you have a drop down that provides a pop-up box, kind of like a dialog box that allows you to provide different icons with a text label. Because of its similarity to the combo box control, see the later section combo boxes. We call this a combo icon button. See figure 21.10. So a combo box control, we will discuss that later, but it is similar to this combo icon button. So basically, it consists of a group of icons. So it's a variant of a regio icon button. So it's like more like this, right? A regio icon button. But it's not always showing, so it saves screen space. So this combo icon button from Microsoft Office is a group of icon buttons that behave like a combo box. Normally in Windows, like a single icon button with a small down arrow to its right. If you click the arrow, it drops down a menu of several icon buttons from which users may choose. The selected icon button then appears on the toolbar next to the arrow. So whatever icon you choose here will be shown here. That's where this complexity of these icons that I was talking about. So because it is combining these different objects, adjectives, adverbs, and nouns. Clicking the icon button itself actuates the imperative indicated by the selected state. So when you click something here, there, and then click that this imperative control, it will apply to that selected state on your content area. Like menus, icon buttons also should activate if the user clicks and holds the arrow, drags, and then releases over the desired selection. So it's like a menu. When you click menu, it will pop up a dialog box. Here, it will pop up a group of icon buttons. And if the user clicks and holds the arrow, drags and then release over the desired selection, then it will choose that verb or a change. It could be an attribute changer such as adjective or adverb. Variation on combo icon buttons include drawing a small downward or right pointing triangle in the lower right corner of the combo icon button icon in place of the separate down arrow that is seen in Microsoft toolbars. Adobe products use this variant in their Palette controls. The user must click and hold the icon button itself to bring up the menu. So for Adobe, it has to you need to action to show this icon. Click and hold, kind of like right click, which provide a more configuration for that object. Adobe products use this variant in their Palette controls. The user must click and hold the icon button itself to bring up the menu, which in Adobe Palette controls unfolds to the right rather than down, as shown in 21.11. So when you click that, usually it will pop up the it from its bottom right to bottom right and then downwards. So kind of like when I click this, it's the same behavior, kind of like right click properties. These combo icon buttons taken from Adobe Photoshop and left Mozilla Firefox show the diversity of idiom applications. In Photoshop, the combo icon button is used to switch between the various modal cursor tools. Whereas in Firefox, it is used to select a previously visited page to return to. In the first example, it is used to configure the user interface, whereas in the second, it is used to perform an action. So here, you configure an interface or a noun using these adjectives or adverbs. Here, you perform this imperative control. So it is the dual use. Yeah. So these controls evolve over time, which makes it allow us to do more with less space on the screen. Now, you can vary this idiom quite a bit. Creative software designers are doing just that in the never-ending bid to cram more functions onto screens that are always too small. This is an excellent control idiom for sovereign posture applications with which users interact for long hours. Working a menu with relatively small targets demands sufficient manual dexterity. But this is much faster than going to the menu bar, pulling down a menu, selecting an item, watching the dialog deploy, selecting a color on the dialog, and then clicking the OK button. So it's much faster even though you have to click this small than pulling down a menu and then watching the dialog deploy and then selecting a color, for example, and then hitting OK. So that's more less action, especially if you are using this for long hours. With the introduction of ribbon control idiom, Microsoft moved away from traditional combo icon buttons and instead offer yet another variant of this idea, an icon button attached to a more standard menu. So instead of combo icons, just in toolbar, it provides a combination of this combo icon in a ribbon control idiom. Later we will gonna discuss how an edit also was combined in this combo icon box. So clicking the icon button fires off an imperative control. Clicking the arrow, so if you click the button or if you click the arrow to the right or below of the button, it launches a menu with related but less frequently accessed functions. So these are the default functions that you see, but clicking that allows you to configure it more. Now, Microsoft Office Ribbon Control contains a new variant of combo button icons. Clicking the button launches an imperative, and clicking the arrow opens a more traditional menu of related functions. List controls. List controls allow users to select from a finite set of text strings, each representing a command. So, list controls are usually for bounded input. So, if you have predetermined input and you don't want user, which we will discuss this further, it is usually use a list control. So it is a form of control as well for us to again manipulate an object, or the kind of like use an object programming in the back end, because that's really what we are doing, kind of like making us a developer that allows it to change our interface. So finite set of strings, each representing a command, object, or attribute. So here it could be a command, or it could be a noun, adjective, or adverbs, or object or attribute. These controls are also known as list boxes or list views. Depending on which platform and control variant you are talking about, like radio buttons, list controls are powerful tools for simplifying interaction because they eliminate the possibility of making an invalid selection. So the radio button as well, or all these icons, actually eliminates our possibility of making invalid selection or making a mistake. So we're like simplifying the command line interface. That's why we move right from command line to GUI as discussed in the previous video. List controls are small text areas with vertical scroll bar on the right edge as shown in figure 21.13. The application displays objects as discrete lines of text in the box, and then the scroll bar moves them up or down. The user can select a single line of text at a time by clicking it. A list control variant allows multiple selection in which the user can select more than one item at a time, usually by shift clicking for continuous or CTR clicking for discontinuous item. So for continuous or discrete object, you can use a shift and then click, but for discontinuous such as this word or text in OneNote, you can use CTRL click for this list if it's a list control. Let's see. But here's the example. So that's a variant of a list control. So again, it's type common type of. So this list control are more sophisticated version. So before we discussed selection control. So until so it started from box, right? Checkbox or radio button to until a ribbon or a combination of combo icon. Now we are in list control. So these are the first sophisticated way to represent our functions on the back end. So on the left is a list control from Windows. The images on the right shows a window drop down menu in its closed and open states. The drop down menu discussed previously can also be considered a variant of the list control. This ubiquitous controls shows only the selected item in a single row until the control is clicked or tapped. Doing so reveals other available choices as shown in figure 21.13. So when you click or tap this, it will reveal the other other controls that is available. Apple's iOS operating system has introduced gesture-based variant of the list control, sometimes called as barrel control. So this, what you see is actually a barrel control, which is a more sophisticated version of list control. But it all started with list control. In it, the list of text items are rendered to appear as though they are wrapped around a cylinder that you rotate by swiping until the desired item is centered in the control. So when you swipe that, you immediately know. So basically, this GUI is an innovation on the UI, as you can see, on how we actually represent commands or functions or object-oriented programming in the back end, which you have this object, verb, and its properties. In it, the list of text items are rendered to appear as though they were wrapped around a cylinder that you rotate by swiping until the desired item is centered in the control. The interesting twist on this control, beside its barrel-shaped rendering, is that it can contain independently scrolling columns. This clear approach merges several list controls into a single widget as shown in figure 21.14. So these are a complete widget, kind of like an organization of related controls. So that's what we called controls. This is the building blocks of the interface on most of our technologies. Now, iOS supports a gesture-based barrel control list view variant that also supports multiple independently swipeable scrolling columns. The barrel control thus can merge several related list controls into a single widget. So in the back end, you just need to command this barrel and it will compile this. Early list control handled only text. Unfortunately, that decision often affects their behavior to this day. A list control filled with line after line of text unrelieved by visual symbols is a dry desert indeed. So the first version of this is not is actually handled only by text, which is this list. We're listing a controls using text. So here are the first version. However, it looks like a desert. However, starting with Windows 95, Microsoft has allowed each line of text in a list view control to be preceded with an icon without the need for custom coding. So Windows, the operating system, manually added that for the benefit of the programmer. So we don't need to program each icons at the left. So there's an icon aside from the text. A newer convention is to use the list items in the drop down or other list view control as a preview facility. So a newer, more sophisticated version of application of list control or a list view control. A newer convention is to use the list item in a drop down or other list view control as a preview facility. This is commonly used in cases where the control functions as both a selection control and an imperative control, such as when you select a style in Microsoft Word. So here you use this selection and imperative, again the command or the verb, and a combination of command and noun control when you select a style in Microsoft Word. So here when we select a style of the font, we're actually using that version because it provides us a list items in a drop down or list view control as a preview facility. So on the left is a list control with icons from Windows that allow users to visually identify the applications they are looking for. On the right is the style drop down list from Office 2010. So it's actually a style drop down list where it provides a pop-up menu where you can choose the style. Here, the items in the list provide a preview of the effects of their selection. So here is a combination of selection and imperative control. When you click that, we're actually applying two kinds of functions in the back end. So design principle, distinguish important text items in list with graphics icon. So the important distinguish this with graphic icons for immediate or expert users. So list view are true to their name, good for displaying list of items and allowing users to select one of or more of them. They are also good idiom for providing a source of draggable form items though not with the drop-down variant. If the items are draggable within the list view, this makes a fine tool for enabling the user to put items in a specific order. List view, so we're basically sorting list in order. So here, we can provide a drag and drop function for us to provide more complex manipulation or commands in just one click. Or as you can see, the click, the scroll, the manipulation, the double click provides us a lot of functions, objects, verb, adjectives in the back end, but we're actually doing that in GUI or with less space. So that's what makes it more sophisticated. So list view are the more sophisticated version of controls, which allows or provide multiple functions and multiple facilities with drag and drop in just a few icons. Earmarking, generally speaking, users select items in a list control as input to some function, such as selecting the name of a desired Generally speaking, users select items in a list control as input to some function. So when you click that items in this list, you're actually sometimes dragging it to apply a function on a selected area, such as selecting the name of a desired font from a list of several available fonts, such as here in home, or this. So that's selection in a list control is conventional, with a selected item shown using the highlighted color. So list view in list control is still the same. It came from list control, but list view are just more sophisticated. Selection in a list control is conventional, with the selected item shown using the highlight color. So the selected item actually is highlighted. So that's one of the properties of earmarking. Occasionally, however, list controls are used to select multiple items, and this can introduce complications. The selection idiom in list controls is well suited for single selection, but is much weaker for multiple selection. For those list view, though, we can use control and then click to select multiple of that now. It used to be that those are not well suited for multiple selection. In general, the selection of multiple discrete objects works adequately if the entire playing field is visible at once. So since we are scrolling in this list views or multiple selection, we cannot see all at once like the icons on a desktop. If two or more icons are selected at the same time, you can clearly see this because all the icons are visible at the same time. But if the full of discrete items is too large to fit in a single view and some of it must be scrolled off screen, the selection idiom immediately becomes unwieldy. This is the normal state of affairs for list controls. Their standard mode of selection is mutual exclusion. So when you select one thing, the previous selected thing is deselected. So one of its main properties of the list control, which is more sophisticated version of selection control, is it's mutually exclusive. It doesn't support additive selection, which we discussed in the previous video. Thus, it is far too easy in the case of multiple selection for users to select an item, scroll it into invisibility, and then select a second item, forgetting that they have now deselected the first item because they can no longer see it. The alternative is equally unpalatable. The list control is programmed to disable the mutual exclusion behavior of a standard list control in its selection algorithm. This allows user to click as many as they like, with all remaining selected. So there's an alternative in which we would program this list control in the backend to disable that mutual exclusions. So it's actually, there's an algorithm for this, I just forgot, and data structure that support this. But yeah, it's actually selection algorithm, but we can disable that. However, that would not work as well because it's equally unwieldy if it's too large or it's not visible at the same time. Now, this allows users to click as many items as they like with all remaining selected. Things now work perfectly, sort of. The user selects one item after another and each one stays selected. The fly in the ointment is that there's no visual indication that selection is behaving differently from the norms. So there's no hinting. It's just as likely that the user will select an item, scroll it into invisibility, and then spot a more desirable second item and select it, expecting the first unseen item to automatically be deselected because the control is mutually exclusive. You get to choose between offending the first half of your users or the second half. It just so happens that we already have another well-established idiom to indicate that something is selected, the checkbox. Suppose, we vanish or remove the checkbox from our idiom, but now we can actually put that into good use, but into more sophisticated list views. Suppose we added the checkbox, so this is called earmarking. Suppose we added the checkbox to every item in our problematic list control. So instead of programming it for just this control, we put a checkbox. Not only would the user clearly see which items were selected and which were not, but he also would clearly see that the items were not mutually exclusive. So this where this checkbox square for not mutually exclusive came from, also applied in the survey. So this would solve both of our problems in one stroke. So you may think that highlighting just that in list control or this actually will solve, but no, it actually get the checkbox from the mainstream. Not only would the user clearly see which items were selected and which are not, but he also would clearly see that the items were not mutually exclusive. This would solve both of our problems in one stroke. So here, combination of checkbox and radio button. Selections normally is mutually exclusive operation. When the need arises to discard mutual exclusivity to provide multiple selections, things can become confusing if some of the items can be scrolled out of sight. Earmarking is a solution. Put checkbox next to each text item and use them instead of selection to indicate the user's choices. Checkboxes are clear, non-mutually exclusive idiom and a familiar GUI idiom. Users grasp the working of this idiom right away. So dragging and dropping list. So because we manipulate objects and verbs to achieve our purpose using this digital or GUI, this is actually how we do this. It was intelligently designed from the back end and then presented here so that we can immediately learn or make multiple selection or functions in one strip of a click. So that's the power of this combination. Now, dragging and dropping from list. So this is the more sophisticated, as was discussed in the previous video. So if the list were part of our report writing applications, for example, you can click an entry and drag it to the surface of the report to add a column representing that field. So here you can click and drag. So as you can see, it became more sophisticated controls uh, because drag you can click an entry and drag it to the surface of the report to add a column representing that field. Uh, it's not selection in the usual sense because it is completely captive operation. So it's not selection like what we discussed in the previous video, and it's not like a selection in a list like this control or checkbox or button in the sense because uh, it is completely captive operation. Without a doubt, many applications would benefit if they used list controls that supported dragging and dropping. Such draggable items can help users gather items into a set, providing two adjacent list controls, one showing available items and other showing chosen items is a common GUI idioms. So here, the dragging and dropping capability of mouse is applied to two list control idioms, which one showing available items and the other showing others showing chosen items, such as here an about face was chosen and these are the available items. So we actually created two list control type of controls here without even noticing because we've used to this idiom. This dialog from Microsoft Express would benefit from ability to drag a contact from the list on the left into the two CC and BCC list. So this is actually a list control as well because you can click this to C BCC. Now if you are able to click and drag here, you combine multiple function in smooth actions. The arrow button functionality is a bit less clear since the list that the contacts are copied to are below the list being copied from rather than adjacent to it. Note also the unfortunate use of horizontal scroll bar, but luckily the dialog can be expanded by dragging the lower corner. So this this dialog, or it's just an idiom as well, allow us to expand this, right? However, we should avoid this horizontal, which we will explain later. It is so much more pleasant when the idiom is buttressed with the ability to just click and drag the desired item from one box to another without having to go through the intermediate steps of selection and function invocation. So instead of figuring out in the back end again the object, the verb, noun, adjective and adverbs, instead of configuring in each action function invocation by changing its properties and selecting it, you just smoothly click and drag. Ordering list. Now since we have developed this list a more sophisticated way of representing controls, now we're ordering list. Sometimes the need arises to drag an item from a list control to another position in the same list control. This need arises more often than most interaction designers seem to think. Many applications offer automatic sort facilities for important lists. Window Explorers, for example, lets you sort files by name, modification date, type, and size. That's nice, but wouldn't it be even better if users could order them by importance? Algorithmically, the application could order them by frequency of user access, but that wouldn't always get the right results. So if you put an algorithm, you could determine what's the frequently accessed by monitoring their usage, and then you can put at the top the most frequent access, but it wouldn't be accurate all the time. Also adding a factor how recently a file was accessed would get closer but still wouldn't be exactly right. Why not let users move what's important to them to a region at the top and sort those things separately in alphabetical or whatever order, in addition to sorting the full directory below. For example, you might want to rearrange a list of people in your department in descending order by where they sit. So why not let a users move things that important to them at the top and sort those things separately in alphabetical or whatever order. In addition to sorting the full directory below. So you can sort that, but you can also apply the manual sorting on whatever position you want. This is the kind of customizing that an experienced user wants to do after long hours of familiarization with an application. It takes a lot of effort to fine-tune a directory like this, and the application must remember the exact settings from session to session. Otherwise, the ability to reorder things is worthless. So it takes a lot of programming to do this, but it's worth it, especially if you want this app to be usable. And then also, the application must remember the exact settings from Windows to Windows or session to session. Otherwise, the ability to reorder that list of controls is worthless. Being able to drag items from one place to another in a list control is powerful, but it demands that auto-scrolling be implemented. See chapter 18. We discussed that. So aside from auto-scrolling, you also must provide a list control that are able to drag and drop. You also must map it to your auto-scrolling. If you pick up an item in the list but the place you need to drop it is currently scrolled out of view, you must be able to scroll the list view without putting down the drag object. So if it's not in your current view, again, this desktop application are operated using views, you must be able to scroll that on the different views in the application. Horizontal scrolling in list. List controls can also be made to scroll horizontally. This feature allows developer to put extra long text into the list controls with a minimum of effort. Text should only be scrolled horizontally in large tables such as spreadsheets, where lock row and column headers can provide context for each column. So we should avoid this is what I'm talking. We should avoid the scrolling of horizontal text. So it only be scrollable for spreadsheet application where the row and column headers is locked and can provide context for each column. When a text is scrolled horizontally, it hides from view one or more of the first letters of every single line of text showing. Design principle avoids scrolling text horizontally. Can you allow the users to enter aliases for the longer entries? Can you use graphical entries instead? Can you use tooltips? Ideally, you should also consider where you can widen the control. Can you rearrange things on the windows or dialog to expand horizontally? So if you have long text, maybe you could divide that, or you can use a graphical entries or tooltips instead in place of that. So you can also widen the control available in that list view if you must. Entering data into a list. Modern list entry controls discussed later in this chapter offer an edit in place facility. So the modern list allows you to edit it. So Windows Explorer uses both of these controls. You can see how they work. by renaming a file or directory. You then enter whatever changes you want. Items that can be edited in other circumstances should, when displayed in list controls, be editable there as well. So items that could be edited, especially for authoring tools in this file, like in a directory, should be available for edit in list controls. The edge case that makes edit in place a real problem is adding a new entry to the list. Most designers use other idioms to add list items. So, where the edit, it seems like the edit for list or unediting a name is not a problem, but adding a new entry, it's also a form of edit, is where the problems goes. Most designers use other idioms to add list items. Click a button or select a menu item and a new blank entry is added to the list, kind of like the right click model window and then add new folder of windows. It would be more sensible if you could say double click in the space between existing entries to create new blank entry right there, or at least have a perpetual open space at the beginning or end of the list with the click to add entry label on it to make it discoverable. Again, we need to make it discoverable, otherwise it won't be used. Those functions won't be used. A lot of functions are actually not being used. So another solution to this problem is the combo box, which we'll talk about in a moment. Drop down in pop-up list. Drop down list, also called pop-up list, take the place of a stack of radio buttons. So instead of a stack of radio buttons, which could combine, takes a lot of space, which is more better than command, right, in the previous version of controls. This is even more better. This gives user a compact way to make a single selection from a list, figure 21.13. Where's that? 21.13. So here, so you have a drop down or pop up. The current selection is shown when the pop-up list closes. Generally speaking, pop-up lists, unlike their command-oriented cousins in the menu bars of desktop applications, focus on selecting objects rather than executing commands. So this is one of the characteristics of the drop-down list. They are more on selecting objects than executing the verb. So selecting the noun, kind of like the first a selection control rather than the imperative control. However, they can sometimes immediately affect the display of information if, for example, they are used as a part of live search filter or as the mechanism for navigating to a page on a website. So they can also use for immediately affecting a display of information as a selection control. For example, if they are used as part of a live search filter. So if it's a search filter, a drop down where you can choose the filter, it immediately change it, kind of like a selection control, the noun and application of verb instead of just selecting an object, or as the mechanism for navigating to a page on a website. Combo boxes, the combo box, so again, these are all part of selection control, more sophisticated, sorry, list control rather. So those are more sophisticated of combo boxes is as its name suggests, a combination of a list box and edit field. See figure 21.8. So here you have an edit field here, Cambria. So in this text box, you can search what you want. So that's the edit field. However, you also have this list box or list text. It provides an ambiguous method of data entry into a list control. As with normal list boxes, a drop-down variant has reduced impact on real estate, screen real estate. The word font selection drop-down combo box allow user to select a font from the drop-down list or simply type the name of the desired font into the text field. For single selection, the combo box is a superb control. For a single selection, the combo box is a superb control. You can use the edit field to enter new items, and it also shows the current selection in the list. When the current selection is showing in the edit field, the user can edit it there, sort of a poor man's edit place. So here actually you can edit as well. For a single selection, the combo box is a superb control. You can use the edit field to enter new items in here, and it also shows the current selection in the list. So another controls or function programming in the backend that it provides is this, showing the current selection in the list. When the current selection is showing in the edit field, the user can edit it there, sort of a poor man's edit in place. If it's showing here, the user can edit it here. So you can actually edit here and then search for what you want. Because the edit field of the combo box shows the current selection, the combo box is by nature a single selection control. There is no such thing as multiple selection combo box. Single selection implies mutual exclusion, which one of the reasons why the combo boxes has replaced groups of radio buttons for selection from among mutually exclusive options. So since this replaced radio buttons, and as you remember, those are for mutually exclusive algorithm in the backend, a selection algorithm. Other reasons include space efficiency and the ability to add items dynamically, something that radio buttons cannot do. So another reasons for it being mutually exclusive is for space efficiency. Since it's a drop down, it saves space and it has ability to add items dynamically, something that radio buttons cannot do. When drop down variants of the combo box are used, the controls shows the current selection without consuming space to show list of choices. So if you use the drop-down variants of this, it actually do not consume space, but there's actually not a drop-down variant of this. Essentially, it becomes a list on demand, much like a menu provides a list of immediate commands on demand. A combo box is a pop-up list control, so it's a part of a pop-up list control. So I think yeah, it's not a list, it's still a list control, but it's part of a pop-up list control. Where's the pop-up list here? So here, so we can think of this combo boxes. I think we can move this into tab. And stop it. And there you go. So it's now part of it. Let's put A here. And then E1. E2. There you go. So it can reasonably resides permanently on an application's main screen. It can even fit comfortably on a toolbar. So most of the time this is in toolbar, such as here, or ribbon control. Here you can edit this. It is an effective control for deployment on sovereign posture application. Using combo boxes on the toolbar is more effective than putting the equivalent functions on menu. Combo boxes display their current selection without requiring any action on the user's part, such as pulling down a menu to see current status. So you don't need to pull down the menu to check the current status because it immediately shows here. Where is that? Here on home. If drag and drop is implemented in list controls, it should be implemented in combo boxes. For example, being able to open a combo box, scroll to a choice, and then drag the choice onto a document under construction is a powerful idiom. The appearance of a drag handle on a mouse button, on a mouse hover, could provide pliancy. Drag and drop functionality should be a standard part of combo boxes. So you can also put a drag handle on a mouse over that could provide a hint. And drag and drop functionality should be a standard part of that functionality. Tree controls. Tree controls, sometimes called tree views, are list views that can present hierarchical data. They display a sideways tree of visually connected branches of items, often with icons for each entry. The entries can be expanded or collapsed the way that many outlining applications works. It only makes sense to use tree controls, no matter how tempting it may be, in the case where what is being represented is naturally thought of as a hierarchy, such as a family tree. So developers wants this because this is how we think about the data, but you should avoid this at all costs. Entry, because it's not intuitive for users, and then it only makes sense for really a family hierarchy tree of icons. Entry controls. Entry controls enable users to supply information to or set value in an application. The most basic entry control is a text edit field. Like selection controls, entry controls represent nouns to the application. So like a selection that provides nouns as well as a verb, right? But it's one of the nouns, right? That control functions that first provide nouns. Now, here entry controls is a noun as well. So it actually our text field earlier it's kind of like an entry controls, but we will distinguish it for the sake of brevity. Because a combo box contains an edit field, some combo box variants qualify as an entry controls too. Also, any control that lets users enter a numeric value is an entry control because they allow users to set numeric values. Controls such as spinners, gauge, sliders, and knobs fit in this category. Bounded and unbounded entry controls. So another thing is that the spinners, which the measurement in the gauge and the sliders, It's prevalent for music up and knobs, which we're gonna see later. Spinners, it's like the how we change panes for desktop app. We will discuss that further. It's how we differentiate panes or rectangle inner screen. Any bounded and unbounded entry controls. Any control that restricts the available set of values that the user can enter is bounded entry control. Conversely, a simple text field can accept any keyword, character the user types into it. This open-ended entry idiom is an example of unbounded entry control. It is important to understand that we are talking about the quality of the entry control, not the quality of data. So we're talking about the controls or the buttons that we use to input the data, not the data itself. To be a bounded control, it needs to clearly communicate, preferably visually, the acceptable data boundaries to the user. A text field that rejects the user's input after he enters it is not a bounded control, it's a root control. So use bounded controls for bounded input. Most quantitative values needed by software are bounded. If the bounded set of choices is composed of text rather than numbers, you can still use a bounded slider, sometimes called a trackbar, combo box, or list box. So most of the quantitative, such as numbers that needed by our backend or needed input from the user, is quantitative. So if bounded set of choices is composed of text rather than numbers, we can use a bounded slider such as this, a combo box, or a list box. So here is a slider, bounded slider or trackbar. A bounded control let users enter only valid values. It does not let them enter invalid values, only to reject them when they try to move. This figure shows a bounded slider control from the display settings dialog in Windows. So it is from dialog settings, so it's kind of like more a configuration, but it uses a slider. The slider, which is deployed inside the drop-down menu, has several discrete positions. So it's also deployed in a drop-down menu. So it's, as you see, it's a combination of sophisticated controls. As you drag the slider, the legends beside it reflects different allowable screen resolutions, with recommended resolution show even when the trackbar thumb is not on the detent. Spinner controls are a common form of numeric entry control. Sorry, spinners is actually not how we divide it. This is how spinner look like. It's kind of like a dialog box, but here it has an up and down where controls are a common form of numeric entry controls that permit data entry using the mouse, keyboard, or finger. Spinners on desktop contain a small edit field with two half-height buttons attached. So it has an edit field with two half-height buttons attached. That it also have up and down arrow to change this quantitative input, as shown in figure 21.20. On iOS, they're called steppers and have plus or minus buttons side by side, making them much easier to actuate with fingers. So plus or minus buttons are easy because it's just one tap in iOS. So the page setup dialog from Microsoft Word make heavy use of the spinner control. By clicking either of the small arrowed buttons, the user may increase or decrease the specific numeric value in small discrete steps. If the user wants to make a large change in one action or enter a precise setting, he can use the edit field portion for this direct text entry. The arrow button portion of the control embodies bounding, whereas the edit field portion does not. So the arrow is bounded, but the edit you can type as many as you want. Spinners blur the difference between bounded and unbounded controls.
Using either the two small arrows button enables the user to change the value in the edit field in small, discrete steps. These steps are bounded, meaning that the value doesn't go above the upper limit set by the application or below the lower limit. If the user wants to make a large change in one action or enter a specific number, he can do so by clicking the edit field portion and typing in it, just like entering text into any other edit field. Unfortunately, the edit field portion of this control is unbounded, leaving users free to enter values that are out of bounds or even unintelligible. In the page setup dialog shown in figure 21.20, if the users enter an invalid value, the application behaves like most other root applications. It issues error dialog explaining the upper and lower boundaries sometimes, and requiring the user to click the OK button to continue. Dials and sliders, so here's it is. Dials and sliders are idiom borrowed directly from mechanical age metaphors, rotating knobs and sliding levers. Dials are very space efficient, both can do a nice job of providing visual feedback about settings as shown in figure 21.21. Figure 21.21, Corgis iPolysix app, a software synthesizer, makes heavy use of dials and sliders. These are effective interface elements because musicians and producers familiar with them from hardware. More importantly, they provide users with more visual and easy to comprehend feedback about parameter settings than a long list of numbers which aren't that exciting to look at while making music. iPolysix dials make users move their fingers in an arc rather than an up or down or left right swipes, which would be easier to control. Improperly implemented dials can be extremely difficult to manipulate. Sliders are often a better option where space isn't at a premium because they visually suggest the fact that movement is along just one axis. Sometimes developer forces users to trace an arc with their mouse or finger, with mouse or finger distance from the control, therefore controlling the granularity of rotation. Proper implementation of dial should allow linear input in two dimensions. Clicking or tapping the dial and moving up or right should increase the dial's value, and moving down or left should decrease the value. Velocity can control granularity of adjustment. Although sliders and dials are both used primarily as bounded entry controls, they are sometimes used and misused as controls for changing the display of data. For most purposes, scroll bars do a better job of moving data in a display because they can easily indicate the magnitude of scrolling data, which sliders can do as well. So sliders and these dials, these are the sliders and this is the dial button, are used primarily as bounded entry controls, which means like the list and combo boxes we use for quantitative input, but they are sometimes misused as controls for changing display of data. So for changing displays such as this, changing the view, we are better off using scroll bars. However, sliders are an excellent choice for zooming interaction on desktop, such as adjusting the scale of a map or the size of photo thumbnails. Direct manipulation interfaces are better off sticking to the pinch or pinch out conventions of touch technology. So it's better used for zooming in and out, such as adjusting the scale of a map or the size of a photo thumbnails, such as zooming in for that photo thumbnails. Direct manipulation interfaces are better off sticking to the pinch or pinch out conventions of touch technology. Thumb wheels. The thumb wheel is a variant of the dial, but it is much easier to use. On-screen thumb wheels look rather like a scroll wheel on a mouse, and they behave in much the same way. They are popular with some 3D applications because they are compact, unbounded control, which is perfect for certain kinds of panning and zooming. Unlike a scroll bar, they need not provide any proportional feedback because the controls range is infinite. So for thumb wheel, it's infinite. It looks like a scroll wheel on our mouse, so the scroll bar, or that we use for scroll bar, and behave in much the same way. They are popular with 3D, with our compact and unbounded control, so it's like unbounded data, which is perfect for certain kinds of panning and zooming. Panning for 3D, like moving in either direction, or zooming. Unlike a scroll bar, they need to provide any proportional feedback because the control range is infinite. So unlike scroll bar, they need to provide appropriate feedback when it's out of the limit. Scroll bars has an feedback on this right side, right, and then up and down arrow. Other bounded entry controls, these controls typically are bounded because their implementation requires careful thought about relationship between gesture and function. Such control surfaces often provide a mechanism for visual feedback. These controls are most appropriate for situations where users attempt to express themselves in regards to a number of variables and are willing to spend some effort developing proficiency with challenging idiom. Camel's Audio's Alchemy Pro app employs a variety of two-dimensional bounded input controls. These provide good visual feedback, allow users to adjust multiple parameters from a single control, and support more expressive gestural user interactions. Their bounded nature also provide users with context about how the current settings fit within the allowable ranges and eliminates the chance that the user will make an invalid entry. No musician wants to be stopped by an error dialog. Unbounded entry, text edit controls. Let's finish this. The primary unbounded entry control is a text edit control. So the text edit that we see. This simple control allows user to key in alphanumeric text value. Edit field often are small areas where the user can enter a word or two of data, but they can also be fairly sophisticated text editors. I'll just drink something, a moment.
Okay, so let's continue. However, if the desired values are finite, the text edit control should not be used. If the acceptable values are numeric, use a bounded numeric entry control such as a slider instead. If the list of accepted values is composed of text strings, a list control should be used so that users are not forced to type. Users can edit, you need to use a list control for text string, bounded text string. Text edit control for unbounded. Users can edit text within them using the standard tools of continuous selection as discussed in chapter 18 with either the mouse or keyboard. Text edit controls are often used either as data entry fields in database application, including websites connected to databases, as options entry fields in dialogues or as the entry fields in a combo box. So it's sometimes it's usually used for uh, in a in combination with combo box and for connection with database. In all these rows, they are frequently called on to do the work of a bounded entry control. Sometimes the set of acceptable values is finite but too big to be practical for a list control. For example, an application may require a string of any 3D alphabetic characters excluding spaces, tabs, and punctuation marks. In this case, a text edit control is probably unavoidable even though its use is bounded. If these are the only restrictions, however, the text edit control can be designed to reject non-alphabetic characters, and similarly, these allow more than 30 characters to be entered into the field. So as we can see, we can use this as a bounded text edit by disabling those on the back end. However, this brings up interaction issues surrounding validation. So validated entry controls. Typically, you do this by evaluating the user's entry after she finishes entering it and displaying an error message if it's invalid. Validation controls are a type of unbounded text entry control with built-in validation and feedback to the user. This control can validate many formats, such as dates, phone numbers, postal codes, and social security numbers. Make validated entry controls visually distinct from non-validated controls, whether through the typeface used in the text edit field, the border color, or the background color for the field itself. So you need to distinguish the validated entry controls where you need to validate and non-validated control through typeface used in the text edit field, because those are the same text edit control, but the border color, the background color of the field itself should be different, or to this or anything that will distinguish it. Note that password and other security inputs can't adhere strictly to usability concerns, lest they make it usable for hackers and scammers. These kinds of inputs have their own consideration. Active and passive validation. When a control activity rejects keystrokes during the entry process, this is an example of active validation. So if it actively rejects some input, like you can enter a certain number, it's an active validation. A text or set a number, only letters, that's active validation. A text only entry controls, for example, may accept only alphabetic characters and refuse to allow numbers to be entered. Other controls reject spaces, tabs, hyphens, and other punctuations in real time. So others reject spaces, tabs, hyphens. Those are seemingly inconsequential characters. Some variants can get pretty intelligent and reject certain numbers based on live calculations. For example, numbers might need to pass a checksum algorithm. So sometimes it is programmed to check the location and the devices or a certain number of behavior. When an activated validated entry control rejects a keystroke, it must tell the users it has done so. It also should tell the user why the rejection occurred. If an explanation is offered, the users will be less inclined to assume that the rejection is arbitrary or the product of a defective keyboard. So it must tell the user and why. If an explanation is offered, user will be less inclined to assume that their keyboard failed.
The validation then takes place only when the data reaches some threshold, like a set numbers of characters, or the control loses focus. That is when the user is done with the field and moves on to the next one. The validation step also must take place if the user closes the dialog. So sometimes the validation could take place if the control lose focus, like when the user is done with the field, it will only show that red mark. That's what you show in fastword validation nowadays. Now the validation also must take so it also provide this red mark when it reach some threshold, like when the number of characters exceeded. The validation step must also take place if the user closes the dialog. So if they closes the dialog or invokes a function, if the control is not in the dialog, such as clicking place or order in a web page. If the control waits until the user finishes entering data, before it edits the value, this is passive validation. So it's not okay. So if the control or the text edit control waits until the user finishes entering its data before it edits the value, this is passive validation because it waits first because before the user was prompted. The control may wait until an address is fully entered, such as interrogating a database to check if an address is valid. In such cases, each character may be valid by itself, yet the whole may not pass master. A way to address this is by maintaining a countdown timer in parallel with input and reset it with each keystroke. So a way to address this, like an address validation, is maintain a countdown timer in parallel with the input and reset it with each keystroke. If the countdown timer ever hits 0, do your validation processing. So after the user stop like its keystroke, you should start do the passive validation. The timer should be set to approximately half a second. The effect is that as long as the user enters a keystroke faster than once every half a second, the system is extremely responsive. If the user pauses for more than half a second, the application reasonably assumes that he has paused to think, so it goes ahead and analyzes the input so far. To provide rich visual feedback, the entry field could change colors or reveal an icon to reflect its estimate of the validity of the entered data. For example, the field could show in shades of pink until the application judge the valid, when it would change to white or green. So a red could not be valid, could show that it's not valid. Hints: this little pop-up text looks and behaves much like a tooltip. It explains the range of acceptable data for a validation control, whereas a tooltip appears when the cursor sits for a moment on a control. A hint appears as soon as the control detects an invalid character. It also can appear just like a tooltip if the cursor sits unmoving on the field for a second or so. Figure 21.3 The tooltip idiom is so effective that it could easily be extended to other uses. Instead of yellow tooltips offering flyover labels for icon buttons, we could have pink ones offering flyover hints for unbounded edit fields. These hints can help eliminate traditional error messages. In this example, if the user enters a value lower than is allowed, the application would replace the entered value with the lowest allowable value and modestly display a hint that explains the reason for the substitution. It's like a modest little window that display hint that explain the reason. Unlike tooltip, it actually automatically show without hovering your mouse. The user can enter a new value or accept the minimum without being stopped by an error dialog. Handling out of bounds data. In Microsoft Word, for example, if you enter ASDF as a font point size, the application issues a dialog informing you this is not a valid number. It then reverts the size to its previous value or its default value. The error dialog is rather silly, but the summary rejection of your meaningless input is perfectly appropriate. But what if you type the value 9? Sorry, the error dialog is rather silly, but the summary rejection of your meaningless input is perfectly appropriate. But what if you type value 9? The application rejects it with the same curt error message. If instead the control were programmed to think of itself as a numeric entry control, it could help perhaps behave better. It doesn't bother us if the application refuses to accept non-numeric characters, especially if pop-up hints are also employed. But it is incorrect when it says that 9 is an invalid number. So those are the edge cases. Units and measurements. For example, if an application requests a measurement and the users enter 5i, 5in, 5 inches, not only should the control report the result as 5, but it also should report inches. So this is one of the things that we need to be cautious or use autocorrect, though it may be harder on the back end. For that text or validation control or text edit control, we need to automatically convert this to 5 or whatever value we need as an application. If the user enters 5 mm, the control should report it as 5 millimeters. Similarly, well-designed financial analytics applications should know that 5 mm means 5 million. Say that field is requesting a column width. The user can enter either a number and an indicator of the measurement system as just described. Users also could be allowed to enter the word default, and the application would set the column width to its default value. This scenario has problem, however, because the words default and best fit must be in the user's head rather than in the application somewhere. This is easy to solve though. All we need to do is provide the same functionality through a combo box. The user can drop down the box and find a few standard widths and the words default and best fit. Microsoft uses this idea in Word as shown in figure 21.24. For units and measurements, handling out of bounds data, this is how we do it using a combo box with precise measurements. The drop-down combo box makes an excellent tool for bounded entry fields because it can accommodate entry values other than numbers. The users doesn't have to remember or type words like page width or whole page because they are there to be chosen from the drop-down list. The application interprets the words as the appropriate number and everyone is satisfied. Avoid text edit controls for output. If you have text data to output, use a text display control, not a text edit control. So you should not provide text edit control. If you want to show the amount of free space on this, for example, don't use a text edit field because novice users are likely to think that they can get more free space by entering a bigger number. At least that is what control is telling them with its equivalent body language. Use non-editable display controls for output only text. So that's actually a type of control. It only display the necessary text. Display controls are used to display and manage the visual representation of information on the screen. Typical examples include scroll bars and splitters. So here the splitters that what I'm talking about. So for unbounded control, we are using sliders, buttons, etc. For bounded controls to control the input. However, for display or non-editable input, we're using scroll bars and scroll splitters. So screen splitters is what I'm talking that is used to separate panes. These include paginators, rulers, guidelines, grids, group boxes, and those 3D lines called dips and dumps. Text controls, probably the simplest display control is the text control, which display a written message at some location on screen. So display control is a text control. The simplest of display control is a text control that displays a written at some location on the screen. Users can change most information stored in a computer. Why not allow them to change it at the same point the software display it? Why should the mechanism to input a value be different from the mechanism to output a value? In many cases, it makes no sense for the application to separate these related functions. In almost all cases where the so a lot of times it makes no sense for the application to separate these functions, the editable one and the displays text control. But in almost all cases where the application displays a value that could be changed, it should not do so in an editable field so that user can it should do so in an editable field so that user can click it and change it directly. So in most cases, we want the user to be able to edit it where that display is to save screen space. Special edit modes are almost always examples of excise because you need to edit it on outer place instead of directly on that text control. For years, Adobe Photoshop insisted on opening a dialog to create formatted text in an image. Thus, user could not see exactly how the text would look in the image, forcing them to repeat the procedure several times to get things right. Finally, Adobe fixed the problem, letting users edit formatted text directly into an image layer in full WISIWYG fashion, as it should be. Scroll bars serve a critical need in the modern GUI. They enable smallish rectangles, windows, or panes to meaningfully contain large amounts of information. Unfortunately, they are also typically quite frustrating, difficult to manipulate, and waste of pixels. The scroll bar is without a doubt both overused and underexamined. In its role as a window content and document navigator, a display control, its application is appropriate. So it's just a display control because you're not changing anything. The singular advantage of the scroll bar, aside from its near universal availability, is that it provides useful context about where you are in the window. The scroll bar's thumb is the small, draggable box that indicates the current position and often the scale of the territory that can be scrolled. The best scroll bars use thumbs that are proportionately sized to show the percentage of the document that is currently visible. So it's proportion to how much documents you see. And also, while scroll bars are useful for nearly all types of content, scroll bars for pages of text should also show the following: the total pages, the page number, record number, graphic as we scroll, a thumbnail of the page as we scroll. Additionally, many scroll bar implementations are stingy with functions to better help us manage navigation within documents. This should give us powerful tools for going where we want to go quickly and easily. It should provide buttons for skipping ahead by pages or chapters, section, or keywords, buttons for jumping to the beginning and end of the document, tools for setting bookmarks that we can quickly return to, annotated scroll bars that visually show the position of search for items on the background of the toolbar itself. The thumb of the scroll bar must be partly transparent for this to work well. Recent versions of Microsoft Word use a scroll bar that exhibit many of these features. So annotated scroll bar that visually show the position of search for items on the backgrounds of the toolbar itself. The thumb of the scroll bar must be partly transparent for this to work well. So here this image shows a limitation of using a scroll bar for navigating the endless stream of time. Dragging a thumb all the way to the end of the scroll bar takes the user 1 year into the future. This seems a bit arbitrary and limiting. Fine control of scrolling becomes much more difficult. If scroll bar disappears when not in use, it becomes difficult to tweak positioning because movement is required to activate the fine controls. It's therefore not wise idea to use hideable scroll bars for any application where fine-tuning scrolling is necessary. There are some viable alternatives to scroll bar. One of the best is the Document Navigator, which uses a thumbnail of the entire document space to provide direct navigation to portions of the documents. So it allows you, it's a display control as well, to go to the portion of the document. So Ableton Live features a Document Navigator on the top of the arrangement screen that provides an overview of the entire song. The black rectangle denotes which part of the song, the work area, is zoomed in. So here, zoom in on. The navigator provides context in a potentially confusing situation and simultaneously provides a direct navigation idiom where the user may move the rectangle to focus on a different part of the song. So it is a scroll bar as well, but it just looks triangle, but it is a thumbnail type of display control. Many image editing applications such as Photoshop utilize this for navigating around the document when zoomed in. This can also can be useful when you navigate time-based documents such as video and audio. Critical to the success of such idioms is that it's possible to meaningfully represent the big picture of the documents in visual form. For this reason, they aren't necessarily appropriate for long text documents. In these cases, the document structures in outline form can provide a useful alternative to scroll bars. So these are useful for video and audio application. This type of scroll bar or display control. Critical to the success of such idiom is that it's possible to meaningfully represent the big picture of the document in visual form. So this doc is actually a document. Sorry, for Photoshop, a big document is possible to represent in visual form using this type of display control. For this reason, they aren't necessarily appropriate for long text documents. For long text like this, it's not appropriate because it's confusing. In these cases, the document structure in outline form can provide a useful alternative to scroll bars. So an outline document such as that has this hyperlinks that you can click could be that provides a table contents could be an immediate way for you to access the part of the text. A basic example can be seen in Microsoft Word's document map. Splitters are useful tools for dividing a sovereign application into multiple related panes in which information can be viewed, manipulated, or transferred. So you can select and view it, you can change it or edit it, or you can transfer or drag and drop. So those different like an index pane in a email. Movable splitters should always advertise their pliancy with cursor hinting. So it is not always shown this pliancy, but when you move the cursor, it should hint it. In general, a splitter should be unable to be moved in such a way that makes pane's content unusable. So a splitter should be unable to be moved. So in such a way that the content inside that splitter is unmovable. That's why you have a limit on how you can move this the pane of index in your email. In cases where panes needs to collapse, a drawer may be better in idiom. So a drawer is substitute if it needs to collapse. Drawers and levers. Drawers and panes are panes in a sovereign application that can be opened and closed with a single action. It's actually a pane in sovereign. For mobile apps, these are highly utilized. You usually open a drawer by clicking a control in the vicinity of the drawer. This control needs to be visible at all times and should be either a latching buttons or icon button or a lever. A lever behaves similarly but typically swivels to indicate an open or closed state. So it can open using a swivels or closed state. So there it has two states. Drawers are a great place to put controls and functions that are less frequently used but are most useful in the context of application's main work area. So instead of the dialog box, you use drawers. So again, we created a more super sophisticated controls where this GUI came from until drawers. So drawers have the benefit of not covering the main work area the way a dialog does. Property details, searchable list of objects or components, and histories are good candidates for putting in drawers. On mobile devices, horizontally sliding drawers with levers have been employed ubiquitously and successfully to stop primary navigation panes. They take users to different functional screens using the hamburger icon and drawer idiom, first popularized and largely abandoned by Facebook, to content picked from an ordered list, as is typical of many mobile mail applications, or to a UI that provides interaction with the selected drawer items, such as the right-hand chat drawer in the iOS Facebook app that allows you to see the current online friends. Let's move on to the second part, dialogues, one of the most useful as well component of this technology, graphical user interface. Dialogues are pop-up windows superimposed over the application's main window. A dialogue engages users in a conversation by offering information and requesting some input. So it engages the user by offering information and requesting input to configure, usually the functions. When the user has finished viewing the information or selection from options presented, he can dismiss or accept the dialogue. The dialogue then disappears, returning the user to the main application window. So, dialogues are pop-up windows superimposed over the application window, kind of like a drawer. Design principle, put primary interactions in the primary window. It's very difficult to create fluid interactions if you force users through a maze of pop-up dialogues. If a user is the chef and the application is the kitchen, a dialogue is the pantry. The pantry plays a secondary role, as should dialogues. They are supporting actors rather than lead players. And although they may move action forward, they should not be the engines of motion. Primary actions and controls for an application belong in its main screen or window. Appropriate use of dialogues. It's sometimes useful to take users out of their flow to force them to focus on a particular questions. This is particularly true for actions that make immediate and major changes to the application states. For example, a function that allows will-say reformatting of document should be considered a dislocating action. The dialog helps prevent this feature from being invoked accidentally by ensuring that a big friendly cancel button is always present, and also by providing the space to show more protective and explanatory information along with the risky controls. Design principle dialogues are appropriate for functions that are out of the main interaction flow. The dialog can graphically show users the function potential effects with a thumbnail of what the changes will look like. So it shows a preview of what the changes look like, and of course a robust undo function should be provided for such actions. Dialogues are also well suited for concentrating information related to a single subject, such as the properties of a domain object, an invoice, or customer, for example. They can also gather all information relevant to a function performed by an application, such as printing reports. Dialogues are appropriate for organizing controls and information about a single domain object or application function. Similar to menus, dialogues can be effective for users who are still learning an application, because dialogues can be more verbose and structured. So this combination of the function, object, or application functions and in organizing information makes it suitable, like a menu that provides more pedagogic interface for functions that are also accessible through direct manipulation in the main application window for new users. However, this sort of interface also can be more effectively placed in expandable, modeless control panels or drawers or contextual toolbars in modern desktop apps. Dialog serves two masters: the frequent user who is familiar with the application, and users who is familiar with the application and uses dialogues to control its more advanced or dangerous facilities, and the infrequent user who is unfamiliar with the scope and use of the application and who use dialogues to learn the basics. Basic dialogue interactions. Most dialogues contain a combination of informative text, interactive controls. Combination of text and interactive controls, like an icon or button, and associated text labels. So not just text and then icon and then controls, but also labels. It's important to create dialogues in accordance with good visual interface design practices and ensure that they use GUI controls appropriately. When instantiated, a dialog should appear on the topmost visual layer so that it is obvious to the user. Subsequent user interactions may obscure the dialog with another dialog or application, but it should always be obvious how to restore the dialog to prominence. So when you instantiate this like a drawer, it should appear on the topmost visual layer that is obvious to the user, otherwise they won't notice it. Subsequent user interaction may obscure the dialog with another dialog or application. So a dialog should have a title that clearly identifies its purpose. If a dialog is a function dialog, the title bar should contain function's action, which is the verb, if you will. Design principle: use verb in function dialog title bars. If the dialog is used to define an object's properties, the title bar should contain that object's name or description. So if you are using this to define the properties of an object or to manipulate it using the controls, icon, and text labels that are asking for user information, you should name that name or description using that verb. The properties dialogues in Windows work this way. When you request the properties dialog for a directory name backup, the title bar says backup properties. Similarly, if a dialog is operating on a selection, it can be useful to reflect a truncated version of the selection in the title to keep users oriented. Design principle: use object names in property dialog title bars. So for property dialogs, use the object names. Since object, you're usually changing properties for objects, but for functions that apply, you need to use the verb. Most conventional dialogues have at least one terminating command, a control that. So that terminating command is actually a control. When activated, causes the dialog to shut down and go away, and most often some other function that was the point of the dialog. So sometimes clicking that control, that's just OK, instantiate another function that related to that. So that's where make its control complicated, because now you're applying this controls inside this dialog box or inside this windows where that the desktop came from. Most model dialogs offer at least two. When activated, causes the dialog to shut down and go away, and most often some other functions that was the point of the dialog. Most model dialogs offer at least two push buttons as terminating commands, OK and cancel, although the close box in the upper right control is also terminating command idiom. It is technically possible for dialogs not to have terminating commands. Some dialogs are unilaterally launched and dismissed by the application for reporting on the progress of a time-consuming function. For example, their designers may have omitted terminating commands. This is poor design for a variety of reasons, as we will see. So some of these dialogues are actually launched and dismissed by application for reporting only, such as like alerts, some dialog box. It is technically possible for dialogues to have terminating commands on itself, which is a poor design. Modal and modeless dialogues. Dialogues come in two flavors: modal and modeless. Modal dialogues are by far the most common variety. So the most common here is the modal, because this modeless, we replace this modeless with the toolbar or this drawer. After a modal dialog opens, the owner application cannot continue until the dialog is closed. All the controls and objects on the surface of the owner's application are deactivated for the duration of the modal dialog. So if that modal dialog is activated, all the controls and objects on the worker's main window will be deactivated. Of course, the user can activate other applications that's not related to that main content area while modal dialog is up, but the dialog stays there indefinitely. When the users go back to the application, the modal dialog is still there waiting. In general, modal dialogues are easier for users and designer to understand. There may be too many modal dialogues and they may be weak or stupid, but their purpose and scope usually are clear to users. Some modal so it's clear to users, though because it's the most common, unlike the modal dialog box. Some modal dialogs operate on the entire application or the entire active document. Others operate on the current selection, in which case the user can change the selection after summoning the dialog. Because modal dialogs stop only their owning applications, they are more precisely described as application modal, since they only stop the related application to it. Some modal dialogs it actually operate on entire application, or sometimes an active entire document on the window, such as a Microsoft Word. Others operate on the current selection. So it really depends, such as the right-click property pop-up. I change its property. It's also possible to create a system model dialog that brings every application in the system to a halt. In most cases, applications should never have one of this. Their only purpose is to forestall or report catastrophic occurrences, such as the hard disk melting, that affect either the entire system or real-world processes. Modeless dialogues are less common than their modal siblings. When a modeless dialogue opens, the parent application continues without interruption. So the parent application that instantiates that window does not stop because it's modeless. That makes it modeless. The various facilities and controls, menus, and toolbars, icons, text label of the main window remain active and functional. Modeless dialogues have terminating commands too, although their conventions are far weaker and more confusing than for modal dialogues. A modeless dialogue is much more difficult to beast to use and understand, mostly because the scope of its operation is unclear. It appears when you summon it, but you can go back to operating the main window while it stays around. This means that you can change the selection while the modeless dialog is still visible. So it's like a find and replace of window. So you can go to the operating main window, which again adds to the Windows Management exercise. If the dialog acts on the current selection, you can select change, select, change, select, and change all you want. Select, change, or select, edit, or multiple functions on that objects. For example, Microsoft Word find and replace dialog allows you to find a word in text which is automatically selected. Makes edit to that word and then pop up to the dialog which has remained open during the edit. So it's still open while you're editing. In some cases, you can also drag objects between the main window and a modeless dialog. These characteristics makes them effective as a tool or object palette. So the object palette or tool palette are now the new modeless dialog. Differentiating modal and modeless dialogs. First, modal dialogs must include one or more terminating commands, usually in the form of large push buttons. At the bottom of the dialog, design principle differentiate modeless dialogs from modal dialogs. So modal dialogs should have one or more terminating commands such as OK and cancel. Second, modeless dialog should not use terminating commands, buttons. So it should not have cancel. Instead, they should use the close control in its window title bar. So again, it went back to control. Design principle, do not use terminating button commands for modeless dialogs. That's why it's hard to understand this, because it's a combination of controls came from object-oriented programming concepts. That's why it's hard to explain it, though we can use this because it's visually intuitive and we used to we are used in this complex setup. So third, modal dialog should not close controls in the title bar. Should not use close controls in their title bars, not only to help differentiate them from their modeless brethren, but because the function executed by the close control may be unclear to users, thus clicking it cancel or confirm what's been entered in the dialog. That's why you don't see this close in the modal dialog. Design principle, don't dynamically change the labels of terminating buttons. Issues with modeless dialogs, they are visually very similar to modal dialogs, but they are functionally very different. Conversely, the current selection can easily change during the lifetime of a modeless dialog. What should the dialog do then? For example, if a modeless dialog modifies text, what should it do if we now select a non-text object in main window? Should the controls in the dialog become disabled, change, or disappear? Questions such as this require careful analysis as well as close examination of persona needs, goals, and mental models. Consequently, modeless dialogue can be much more challenging to design and implement than modal dialogues, which avoid these issues by freezing the application state. Modus dialogues frequently have several buttons that immediately invoke various functions. So it immediately applies to the main screen. The dialog should not close when one of these function buttons is clicked. So this dialog should not be, because it will not be visible. It is modeless because it stay around for repetitive use and should close only when the window close control is clicked. Modus dialog must also be incredibly conservative of pixels. They will be staying around on the screen of occupying the front and center location, so they must be extra careful not to waste pixels on anything unnecessary. Modeless dialogues and undo. The changes made from a modeless dialog are immediate, occurring as soon as any entry or control in the dialog is changed. There is no concept of cancel all my actions. Dozens of separate actions may have performed on number of selections. The proper idiom for this is the undo function, which is the active application for wide for all modeless dialogues, such as in toolbar or ribbon control. So that's why you only see that you don't see a cancel button, because dialogues because it is meant to not disrupt interaction flow. This all fits together logically because the undo function is unavailable if a modal dialog is up but still usable with modeless ones. The only consistent terminating action for dialogs is close, which should be accessed from the window close control on the title bar. The only consistent termination action control is close, which should be accessed from the Windows control of the title bar. Furthermore, if the close button activates a function, in addition to shutting the dialog, you should have created a modal dialog that should follow the conventions for the modal idiom instead. So this is what I'm saying. Closing something sometimes invoke another function, so you should avoid that and put in modal dialog instead. Modeless dialogs and sidebars. Any modeless dialog that is intended to provide persistent support to activities in the main window is a good candidate for recasting a sidebar control pane. See chapter 18, which is in the previous video. They have all the advantage of modeless dialogs without forcing users to manage the set of controls within a separate floating window that must be moved out of the way of the job at hand. So it manages set of controls and function with a separate floating, but it doesn't occupy screen real estate. As screen resolution have increased, there is less and less reason for banks of controls intended for frequent use in the construction of a document to be placed anywhere but in toolbars or sidebar panes. So because of the increased technology, you should definitely use this. 5 purposes of dialogues. The concepts of modal and modeless dialogues are derived from the developer terms. In that light, 5 fundamental types of information are useful to convey with a dialogue: property, function, process, notification, and bulletin. Property dialogues. Property dialogues allows users to view and change settings or attributes. A property dialog generally modifies the current selection, but it can also be used to set application global properties. So this property dialog are used to view and change settings or attributes of the object. A properties dialog generally modifies the current selection, which is the object, but it can also be used to set application global properties, shown in figure 21.31 later. You can think of property dialog. So mostly it's used for manipulating object properties, like a right click. When you click something and then right click it, you can think of a property dialog as control panels containing configuration controls for the selected object. Property dialogs typically are modeless. When you modify the properties of a selection, these dialogs often are more useful when they are implemented as a task pane or sidebar, rather than as a standard dialog, especially a modal one. So it's task pane or sidebar that pops up when you need it, like a right click. This is true unless they are being used for set once and forget or global property or other infrequently accessed properties. Function dialogs are usually launched from a menu. They are most frequently modal dialogs, and they control a single function, using a printing, modifying a large number of database records, inserting objects, or spell checking. So this like a verb dialog. It's usually an act launched from a menu. They are most frequently modal, so it's modal dialog, and they control a single function such as printing, because they organize this into a neat dialog box, modifying large number of database, inserting objects or multiple instance of object, or spell checking. Not only do dialog allow users to initiate an action, but they also often allow users to configure the details of the action's behavior. So it allows you to configure because it's in the modal box. In many applications, for example, when the user wants to print, she uses the print dialog to specify which pages to print, the number of copies to print, which printer to output to, and other settings directly relating to the print function. The terminating OK button on the dialog not only confirms the setting and closes the dialog, but also executes the print operation. This common technique combines two functions, configuring the function and invoking it. So you can configure that in that dialog box, and also it also invoke it. Just because a function can be configured, however, doesn't necessarily mean that the user will want to configure it before every invocation. It's often better to make two functions separately accessible, although they should also be seamlessly linked. So, but it's not ideal for all of this dialog, because otherwise, every time the user wants to invoke that function, they need to access this modal dialog. If you don't segregate configuration and actuation, users can be forced to confront considerable complexity even if they want to perform a routine task in a simple manner. Process dialogs are launched at an application discretion rather than the user's request. When an application begins a process that will take perceptible quantities of time, anything over a second, it must make clear that it is busy but that everything is otherwise normal. Design principle inform the users when the application is unresponsive. Many applications are currently rely on active wait cursor hinting, turning the cursor into something like spinning beach ball or hourglasses, and disabling further clicks until the process is complete. A better, more informative solution is a process dialog. Each process dialog should make clear to users that a time-consuming process is happening, that things are completely normal, how much more time the process will take, how much more objects or the items need to be operated on when applicable, how they can cancel the operation and regain control of the application. The more presence of the process dialog satisfies the first requirement, alerting users to the fact that the process occurring, satisfying the third requirement, can be accomplished with a progress meter of some sort, showing the relative percentage of work performed and how much is yet to go. Again guys, thank you for watching. See you on the next video.